Let us now discuss de Broglie's hypothesis. Or simply de Broglie's theory. According to de Broglie, just as light has dual nature, just as light has particle nature as well as the wave nature, even electron also has dual nature. Electron is a particle. We know that. It is a particle, and while revolving around the nucleus, it behaves as a wave. Okay. It is a particle, and while revolving around the nucleus, it is behaving as a wave. So, even electron also has dual nature, just like light has dual nature. Now, when it is behaving as a wave, it will have all the characteristics of the wave. We have already discussed the characteristics of a wave, like wavelength, wave number, frequency, etc., etc. Now, stating this, de Broglie also has derived an expression for calculating the wavelength of electron, which can be given as lambda is equal to h by mv. Now, this is the relation used to calculate the wavelength of electron. Okay. Now, this can be derived simply from two things. One is equal to h nu. The other one is equal to mc square. Now, the first one is Planck's equation is equal to h nu. And the second one, we know that it is Einstein's law of mass energy equivalence. Okay. Is equal to h nu. Let this be equation number 1. Is equal to mc square. Let this be equation number 2. Now, from equations 1 and 2, it can be written as h nu is equal to mc square, right? Because LHS is same, RHS must also be equal. That's what I've written. When these two are same, these two must also be equal. H nu is equal to mc square. Now, let me write this as Hc by lambda is equal to mc square. Because we know that nu is equal to c by lambda. Yes. Let me just cancel out the similar terms. Cc get cancelled. Now, this can be written as lambda is equal to. Now, I'm writing the expression for lambda. Let me take lambda onto this side and mc onto this side. So then I can just write it as lambda is equal to h by mc. Now this is, of course, for a particle moving with a velocity equal to c, that is velocity of light. Now this is for a particle moving with velocity of light. Now in a similar way, for a particle moving with a velocity v, we can write it as lambda is equal to h by mv. This is for a particle moving with a velocity v. Okay. So according to de Broglie, lambda is equal to h by mv, where of course this lambda is a wavelength of electron, h as usual Planck's constant, then m of course is the mass of the particle. Of course, in this case, it is electron. V is, of course, the velocity of the particle. And in this case, because we are dealing with electron, you can take it as velocity of electron. Now, we know that mass into velocity is nothing but momentum. P is momentum. It is nothing but mass into velocity, right? So therefore, lambda can be written as h by p. Even this also is a very important relation. Lambda is equal to h by p. You know, it is applicable in general to those with lesser mass. As we can see from this, that lambda is inversely proportional to, of course, h is a constant. Let me take it as inversely proportional to mass into velocity. You know, lambda will be higher only when the mass is lesser. That is when we can calculate the value of wavelength. So it is in fact applicable to those particles with a lesser mass. Lesser the mass, greater is the wavelength. So it can be calculated. If suppose mass is very high, lambda will be very, very less, so that we cannot calculate it. So it is applicable to particles with the lesser mass. Okay. Coming to the other important formulae. You know, lambda, of course, is equal to h by mv. Let me just derive a relation between lambda, I mean the wavelength, and the kinetic energy. So let me write this as something with kinetic energy in the expression for lambda. For that, let me take kinetic energy is equal to half mv square. Now, v square is equal to, let me keep it here and let me take it to here and take it to this way. So V square can be written as 2ke by m. Therefore, V will be root over 2ke by m. Now let me substitute this in this expression. I'll be getting lambda is equal to h by m into root over 2ke by m. Now on simplifying this, of course I'll get. Now this is of course root m and this is normal m. Normal m in the sense root m into root m. So one root m gets cancelled and another root m can be written as this. From this, I can write the final expression as lambda is equal to root over h by 2 m k. Okay, now this is a very important relation. Lambda is equal to h by root 2 m k e.
Yes.
Now, we know that kinetic energy, in general, energy is equal to charge into potential. So let me
Yes.
write it as E into V. Kinetic energy is equal to E. This, of course, is charge, and V, of course, is potential. Now, let me substitute this in this expression. Then I'll be getting lambda as equal to h by root 2 m into E into V. Lambda is equal to h by root 2 m into E into V. Okay, this is a very important relation again. We can calculate wavelength when velocity, when potential is given. You know, we can derive an expression for wavelength which includes n and z, which we normally use for calculating the wavelength of electron in any orbit of any species. We know that lambda is equal to h by mv, right? Now let me write it as lambda n can be written as h by m into vn. This is nothing but wavelength of electron in nth orbit. You can take any orbit, of course. Now this is the velocity of electron in again the same nth orbit. So lambda n is equal to h by m into vn. Now let me substitute the expression for vn. M into, we know that the expression for velocity of electron in nth orbit is 2 pi k z e square by nh. Now this is the expression for velocity of electron in nth orbit. I've already derived this. So now this can be written as, this nh of course goes into numerator. Then this can be written as nh square by 2 pi m k z e square. Now excluding n and z, substituting the values of all these h, pi, m, k, and e, we get wavelength of electron in nth orbit is equal to 3.33 into the leftover n and z, n by z angstrom. So this, of course, is an important formula, and this, of course, is the simplified version. simplified formula of the same. Now let me explain about the advantage of de Broglie's theory or de Broglie's hypothesis over Bohr's model. You know, according to Bohr, angular momentum of electron revolving around the nucleus, MVR, can be given as n into h by 2 pi. Angular momentum, MVR, can be given as nh by 2 pi. And he says that this n can only have integer values. I mean, the value of n can only be in integers, but can never be in fraction. This is what is technically called quantization of angular momentum. But Bohr failed in explaining why n has to take up integral values only. Why can't it be in a fraction? But that was actually explained by de Broglie. So that is the advantage of de Broglie's theory over Bohr's model. Let me
Yes.
write that as explanation of quantization of angular momentum.
Yes.
Let me go for that. Now, MVR is equal to NH by 2 pi. Let us just rearrange that. See, on rearranging, it can be written as, let me just take this 2 pi onto this side and N, M and V onto this side. Okay. I am just taking 2 pi onto this side, MV onto this side. That's it. So let me write it as 2 pi r is equal to N into H by MV. Now this can be written as a 2 pi r is equal to N into, we know that a H by MV is a lambda according to de Broglie. This, of course, is important. Now the final expression that we got is 2 pi r is equal to n lambda. This can be given as, 2 pi r is the circumference of circle. In fact, this is the circumference of orbit. The circumference of orbit in which the electron is revolving. Must be equal to integral multiples of wavelength of electron. So circumference must be equal to integral multiples. Again, n is an integer. So the circumference of the circle or the orbit in which in which an electron is revolving must be equal to the integral multiples of wavelength of electron. Let's see what if it is so and what if it is not, taking two conditions. What if 2 pi r is equal to n lambda? What does this indicate? If 2 pi r is equal to n lambda, you know, this is when the two ends of electron wave meet. This is how the electron revolves around the nucleus. Now the two ends of electron wave have met. Only when the circumference of the circle is equal to integral multiples of wavelength, then only the two ends of electron wave meet to give a regular series of crests and troughs. Okay. You know what crests and troughs are? Crests, and these are the troughs. Right? We know what a wave is. This is a crest and this is a trough. Now, if 2 pi r is equal to n lambda, then only you get this kind of a thing. You get a regular series of crests and troughs. This is when the wave is said to be. Wave in phase. It is also known as standing wave or stationary wave. More specifically, it is called non-energy radiating wave. Non-energy radiating wave means as long as electron revolves in these kind of orbits which obey this particular relation, they do not radiate energy. I mean, they neither lose energy nor gain energy. This is what was proposed by Bohr. And now, according to this, the Broglie could explain why 2 pi r has to be equal to n lambda, which he in fact got from the same old Bohr's expression, mvr is equal to nh by 2 pi. So, this kind of a wave, I can say that this type of a wave exists. Yes, of course, as long as electron is revolving in a particular orbit, it should not radiate energy. I mean, it should neither gain energy nor lose energy. That is possible only if 2 pi r is equal to n lambda. Coming to case 2. If 2 pi r is equal to, I mean, is not equal to n lambda, okay? See, in case 2, let me take what if 2 pi r is not equal to n lambda. In such a case, the two ends of electron wave do not meet. See, One is here and the other one is here. If 2 pi r is not equal to n lambda, then the two ends of electron wave do not meet to give a regular series of crests and troughs. Do not meet is very important. Now look at what this kind of a wave is called. Now such a wave is said to be wave out of phase. Simply, we can call it energy radiating wave. Now, such a wave does not exist because it is radiating the energy. And by radiating energy continuously, at one point in time, it may fall into the nucleus. But no, it is not happening in the real sense. Electrons are happily revolving around the nucleus in the specified circular orbits. So, if they have to revolve in that way, then they should not radiate.